Hello everyone, my name is Yi. In the previous session, I already briefly introduced the Decord, the efficient video reader. Now, I want to talk about Decord with more details in terms of motivation, usage, advantage, and a roadmap. Before I begin, I want to thank Zhi, who is a main contributor to Decord and helped me preparing the content. Let's see the motivation behind Decord first. In computer vision, videos are inevitably getting more popular as a better format for storing time series image. Video has temporal information and offer way better compression ratio than stack of images. It sounds promising to use videos as input data. However, videos are trickier to handle, especially for training deep video models. First, video has too many redundant frames, especially when motion is slow and the frame per second is big. And right now, in the research domain, people usually process videos in a two-step procedure. First, decode videos to frames, and then use frames as images to train the network. Take an example. Kinetics 400 is one of the most popular datasets in video classification domain, which has about 300,000 videos. It is not that large scale in deep learning era nowadays. Its raw, unresized video take about 450 gigabytes storage space. However, when decoded to video frames, they take 6.8 terabytes disk space. First of all, the data preprocessing, frame decoding, takes time. It takes several days to complete using a common workstation with 32 workers, which means that you cannot start training before you finish all the video decoding. Second, the storage is huge. I know the hard drive is cheap nowadays, but this is still a lot compared to other datasets. Besides, this causes I/O bottleneck during training if you're not using an SSD drive. So, a better and promising way is to read videos directly without this video decoding preprocessing step. Second motivation is current existing video readers do not provide efficient random access in video. Most of them focus on sequential read like OpenCV video capture, as can be seen in the right figure. I believe most of you are familiar with this code snippet. It is from the official OpenCV website. Basically, it is useful when you read videos in an online manner or process video in a sequential manner, but it is not suitable for training deep video models. When you train deep video models, for example, a temporal segment network proposed in 2016, you first divide a video into several segments and pick a random frame from each segment to form your training batches, like the index 9, index 51, and index 102 here. But these indexes are randomly chosen. It may not be the keyframes, and usually they are not. So random access is more important than sequential reading in training deep video models. You can find more details about TSN or the other network in my previous talk. The third motivation is existing video readers has learning curve, which is not easy to learn. For example, if you use OpenCV to read a video offline and want to take the 100th frame, you need to set a frame number and then read it, as shown in this code snippet. Or you can do another way like seeking next and read. It is also complicated. But using Decord, you can operate it as like a NumPy array and get the video slicing down just like indexing in NumPy. No learning cost required. For example, here, the frame is just equal to the video reader, the 99th position. There are also many other reasons to go for Decord. Now let's introduce what is Decord. The goal of Decord is to provide a smoother user experience similar to random image loader for deep learning. The reason we name it Decord is because it is like a reverse procedure of record. In order to make it both easy to use and high efficiency, we provide a Python wrapper on top of hardware-accelerated video decoders, such as FMPEG, libav, and NVIDIA codecs. But we also make several important optimizations. The final goal for Decord is to integrate data reading and data augmentation together into the video loader process and complete everything on GPU to avoid CPU and GPU overhead. Originally, we planned to do a hands-on session for you to try out Decord, but since CVPR turns virtual this year, I will just go through the steps and provide the notebooks later in the website. You can try them out after attending this tutorial. First, let's try install Decord. The installation is easy, just a pip install Decord will be fine. Decord supports multiple platforms, including Windows, Mac, and Linux. It also supports reading videos on either CPU or GPU. But in order to enable GPU reading, you need to build Decord from source, instead of just a pip installation. Now, let's first show some quick examples and show you the ease of usage. So if you want to use Decord to read a video, first you install Decord. You can import video reader from Decord as seen in the code snippet. Then you can pass in the video location and read it. Here you can see that there is a context option, which you can specify either on CPU or GPU. The default is CPU loading. Once you load the video, you can easily get the length of the video by calling len function. After that, you can sample any video frames by just indexing it. The loaded video is like a NumPy array, so everything is pure Pythonic. If you know NumPy, you already know how to use Decord. No learning cost required. Then I want to show you the most useful feature of Decord, efficient batch reading. You can simply pass in a Python list with the desired frame index. Then you will get decoded frames. For example, if I read 1, 3, 5, 7, 9 frames, I will get an array with shape 5 by 240 and by 320 by 3. The 5 indicates 5 frames, and the 3 indicates RGB channel. The middle dimension are just a video resolution. This is useful for 2D-CNs loading videos. Let's use temporal segment network TSN as an example here. If we divide the video into 3 segments and randomly pick 1 frame from each segment, there you go, you can use getBatch to load the 3 frames and start your model training. Writing a video loader has never been easier. Another use case for 3D-CN is to load video clips instead of frames. For example, if we still use temporal segment network with 3D-CNs, the situation will become, I have 3 segments, and I random pick 1 video clip from each segment. Here, I use a clip of 12 frames for illustration. As you can see, there may be a situation that the video indexes have duplication. Many existing video readers have difficulty in this situation, either processing slow like OpenCV because it needs to find the position of previous keyframe and reseek to this particular frame, or cannot do it at all like Lintel. Decord can handle this situation of duplicating frame indexes internally. It creates a buffer to store the previous decoded frames. Once you need it, Decord can directly fetch these frames from the memory, so you don't need to recode them again. This saves lots of overhead. So no matter you are writing a data loader for 2D-CNs or 3D-CNs for training deep video networks, Decord can support you with the easiest solution. In the end, I also want to mention that you can use Decord as a drop-in replacement of OpenCV. If your current pipeline is based on OpenCV, Decord also supports reading frames in CV2 style, like skipping frames, seek frames, and take to the next frame to read the video frame. The only thing you need to do is instead of import video reader from OpenCV, just import it from Decord, and then you can enjoy the speed up. There are several other very useful features I want to introduce to you. For example, you can resize videos while you read the videos. This is needed because most videos right now, no matter from your phone or from YouTube, are 1080p or 4K resolution. However, for video understanding in deep learning field, we are still doing 224 by 224. We don't need that large resolution, and of course, we don't have enough GPU memory to hold that large image as well. If you read the videos in its full resolution and then resize it, it will occupy a lot of computing resources. So we provide a simple solution here. We can resize your video when you read the video, like the example below, by specifying the width and the height of the video. We can get the video frames in its desired shape. All the operation is handled under the hood without affecting user experience and the speed. Another useful feature is to using range during batch reading to reduce Python overhead. Besides, this is a common use case. Most publications nowadays sample videos with an interval. For example, non-local and slow-fast network use a 64-frame video clip, but only sample frame at every other location. TSM only use 8 frames, but sampled from a 32-frame video clip. So, using range function can directly provide you this convenience. As I mentioned earlier, all thing is Pythonic. You can see the final results here. We read 32 frames from the 64-frame video clip. Decord also support getting key frame indexes. You don't need to switch to FFmpeg and do that. Like the code below, we can use getKeyIndexes function to get all the keyframes. They are super easy for downstream tasks like short boundary detection. We can also use the indexes of keyframes to improve video training. Decord provides bridges to multiple deep learning frameworks like MXNet, TensorFlow, PyTorch, and TVM. It is important to have a bridge from Decord to popular deep learning frameworks for training and inference, because this has no overhead. If we just change the data type manually, for example, changing from ND array to torch tensor, it will create additional cost of data copying. The native output of Decord is ND array, as used by MXNet. You can also set it to TensorFlow tensor or torch tensor if you desire. So Decord is a framework agnostic. No matter which deep learning framework you use, you can adopt Decord as your video reader. Now, let's do the efficiency comparison, which is the most compelling reason to change to Decord. First, we do a quick experiment, as in the write code snippet. You can also run this in your terminal right now. It just takes 10 or 20 seconds. What we test is, we load a video and get a random batch from it 11 times, with the first time being warm-up. We can see that Decord only takes 4.5 seconds to finish, while OpenCV takes 7.6 seconds. Decord is almost twice as fast. This shows that we have better random access capability than OpenCV video capture because OpenCV designed is for sequential read. Second, we comprehensively compare to OpenCV and PyAV, which are the two most popular video readers used for deep learning. We can see that in every category, Decord is faster than them. In sequential read, we are twice faster. And for random access patterns like fast random seek and accurate random seek, we are 8 times and 14 times faster, which clearly shows our advantage. The difference between fast random seek and accurate random seek is, do we use keyframes as the funded frame, or we actually need the accurate location. In the case that we care most, which is a real-world deep model training case, we are 6 times faster than OpenCV and 2 times faster than PyAV. To summarize, we make some comparisons to other video readers. For OpenCV and PyAV, they provide a wrapper on top of FFmpeg without further optimization. It is slow in video random access, which impacts the deep video model training. Decord is several times faster as shown in previous slide. For Lintel, it doesn't have keyframe handling capability and cannot batch read video frames when there is duplication. Decord can efficiently handle duplicate batch reading, which is suitable for both 2D and 3D CNS training. For DALI, it is a mature pipeline, but very complicated to use and has to be used together with NVIDIA GPU. We provide bridges to different deep learning frameworks and different hardwares. We will also provide interface to all these video readers to ease the transition to Decord. Here, I want to talk about several previewed features. First is, we are working to integrate data augmentation into video decoding on GPU as well. This will save all the overhead of CPU video decoding, CPU data augmentation, traffic between CPU and GPU, etc. Because all the data augmentation in video is multiple times slower than image loader, we have to do the same augmentation for all the image sequences. So integrating data augmentation into the data loader process sounds very promising. We almost complete this procedure, but the speed improvement is not obvious. It needs further optimization inside the data loader class. The second feature is to integrate a data loader into Decord as well, to introduce a video loader, instead of just serve as a video reader. In this case, we can optimize everything together and fully utilize both CPU cores and the GPU memory. We already started this effort. As you can see on the official website of Decord, you can try Video Loader already. Video Loader is designed for training deep learning models with tons of video files. It provides smart video shuffling techniques in order to provide random access performance. In the future, the Video Loader interface will be all you need for video-related tasks. It will handle video reading, video sampling, video data augmentation, video batchifying into a single video loader. To conclude, we introduce an efficient video reader, Decord. Decord is easy to use and flexible. Most operations are Pythonic, just like operating with NumPy array. It is also efficient thanks to the extensive optimization under the hood. It is several times faster than other video readers in real-world training scenario. Since this is a virtual session, I won't go through the notebook, but welcome to try the notebook in the Decord repo. We hope Decord can be useful to your use case. Please try it out at github.com/dmlc/Decord. Welcome feature requests and contributions. Thank you.